that stud's broken. There's a crack. There's a crack up here. It goes all the way to right there. Eventually, that's going to break and the motor's going to fall inside and wreck a bunch of stuff. Black, purple, brown. Fan wiring is going into a junction box here, and you can't take it very far away before you run out of wires. I've got to prop the top up so I can disconnect it. Brown, purple, and black. There they are. While I'm here, that coil is going to need a little cleaning too. Yeah. You know what I mean, Vern? While the top is off, it's a good time to take care of these leaves. Now make sure you have the electricity off, because water and electricity, they're not the best of friends. That's a good opportunity to make sure your drain works too. Oh, yeah. It's a whole lot better than it was. Alright, time to soak the shaft. Usually these blades get seized on, and I hope that I don't have to break the blade to get it off this motor. And the motor was actually still good, but since the mounts were broke and the top case is broke, it's going to take the same amount of work just to replace it while I'm in here. Preventative maintenance. Prevent this problem in the future. Deal with it now. Well, I'm optimistic. I'm glad it moved at all. Now we get to see if these studs are going to break off. Well, I'm amazed. I figured that motor would just hit the floor there. I put these washers on to stop the cracks a few months ago while I was waiting on a motor replacement to come in. And I figured they would have just seized all the way. Alright, I'm going to take some of the surface paint off because we're going to weld this. I'm not sure if it'll come through there, but we've got this uneven surface. I need to close the gap before I put the welder on. Now it may be hard to see, but the end of this crack is right there. So I'm going to drill a hole as a strain relief. There we go. I need to put one here too. I'm going to fill these in with weld. If you'd like a visual demonstration of why the hole works, just take some piece of paper and start a tear and tear into one of the holes, and then you'll see the tear stops. So the hole actually adds some strength because the fatigue metal doesn't have anywhere else to go. So there's the crack, and you can see it goes all the way to where the stress relief hole is put in. And this one's coming over here. I need to grind out a little more paint. That one's not so bad. And that was not so bad. I think I'll leave these two alone, put some weld here, here, and here. And tool of choice today is the titanium welder from Harbor Freight. For 18 gauge, it's calling for 3.5 speed and B.5 to C. So B.5, 3.5. Alright, it's time to weld this up. I've got one complaint about the titanium welder, and it's not really the welder's fault. but the power on it's so low that it doesn't create a whole lot of light, and you can't hardly see through the weld helmet. So I have to add artificial light like that so that I have good visibility through the helmet. Ugh, that's an ugly first weld. That's actually not a blow through there, that's just my, oh, yeah, it is a blow through. Oops. I got off my line. I can fix it, but I'll do it in a minute. See, I'm out of practice. That one was ugly, this one is tolerable, and the last one might look great. Alright, on this one I might put my hand a little close to the fire. Since I don't have a glove, I'm going to pull my sleeve down. There we go. That looks good. Now we can get to the motor part of the situation. You can see we've got brown, purple, black here. And this is a universal motor, so it's got different colors. Bonus points if you can match up the capacitor. This one takes a 5 microfarad capacitor, and this one also takes a 5. And if you find one that takes a 6 or a 7, then you have to change either the combination capacitor in the unit or just add the matching capacitor to this one and leave your compressor combination unit unattached. Now if you have limited room in your unit, you can cut this shaft if you need to. I won't be needing to do that for this project. These wires are a little shorter than the ones I used to have. This is going to take a little more effort. Brown goes to brown. Purple goes to white. Brown and white stripe gets left off. Black to black. Now I've just got to stuff everything back into this box. I also didn't have to change the motor rotation. So the orange and yellow wires will stay the way they are. This capacitor has seen better days. This is a 15 microfarad capacitor, and the motor actually calls for a 12.5, so I'm going to put a 12.5 back in there. Someone put the wrong one in last time. There's a nameplate right there, and I can't get the camera into the angle to actually show it. But here we go. New stuff. I keep a box full of new stuff. One thing I hate about capacitors is when you open them, the terminals are already right there, and people have a habit of dropping them in their hands. They're supposed to be discharged, but I don't trust it. So I'll go ahead and short these contacts together so it'd be safe to touch, and I'll still be too paranoid to touch it. But that's just me. Yep, that's me being paranoid again. Capacitors can wreck your day. And if you don't remember, to get to this point, there was a panel here on top, and then a panel on the inside, and then there was a panel here, and then you get inside there, and there's a panel here to get to this heater kit. And this annoys me because there are breakers here, and you gotta go through 3 panels to get to them. While I'm in here, this breaker kit is going to be getting replaced too. What you can't really tell on camera, you'll have to take my word for it, is there doesn't feel like there's anything inside of these. Whereas new ones, they snap when they're closed. They snap when they're opened. And these don't really feel like they're working. It's not necessary to have a breaker kit in here because the breakers are right here. Now, if it had been out of eyesight, you know, you could have treated it like a sub panel and kept the breaker kit here, since you need a means of disconnect. But that doesn't apply here. I don't have to take that out. We're going to make it better. Yep, always make sure the power's off. I can't get to the quick release off that den rail with these terminals in the way. So out they go. And there you are. So they snap into a rail, and there's a spring release latch that was right there with the terminals in the way. Alright, let's get rid of this rail. We don't need the den rail anymore. Now, we're going to replace that with this terminal block kit. These already have the male spades in there. And you put your wire in here. This is good for 3 gauge up to 14. And 115 amps on copper or 90 amps aluminum. I don't have much room, so I'm going to need to mount it about like that. Now, I was hoping I could recycle at least one hole. No, I can't if I do it there. I don't like how they got red and black mixed together, but I'm not going to change it. That's just the way they had it. I'm going to keep it the same as it was. Kind of awkward that those are going to be going out to the side instead of the way they were. That might not work. Oh, I can still get the door shut. I don't like that as well though. Voila, no more breaker. Yep, all secure. Now we just need to tidy it up a little bit. I always found it best to put the zip tie on the sticky back first and then put it where you want it to be. So everything tested good, that all works. None of the wires are touching this hole. That needs a cover, but it's going to be fine because I'm going to put another cover on the outside, and no one's going to have their hands in there anyway. Before I close this up, I went ahead and put an Ergo soft starter in here. And if you haven't seen that done, I've got a longer video. You can see right about there. What you do is you take your compressor run wire off the contactor, move it to the starter, move a starter wire to the contactor to replace the one you just moved, and then everything else plugs up, like your capacitor common, your run winding, your compressor common over here, and then you're good to go. Takes like 2 minutes after you figured it out. Turn this on, go to inrush, set the range, and then put the clamp over the compressor common wire way back there. Set this to cooling mode, and we'll see what happens. $50 amps. So this unit could be started by a 50 amp capacitor generator, and that would be about all the generator can handle, unless you had one that could put out 60 amps or 70. That'd be even better. So the soft starter, that was about $250. It's A2L refrigerant certified, so if you've got the new refrigerant, you can put that in there. You don't have to worry about your unit exploding. It's safe. For the rest of the parts, I used the motor. That was $130. The capacitor it needed replacing was about $15, and that terminal block to replace the two breakers that I don't need anymore, that was about $22. So really about $160 is what I needed to spend to get this back in tip-top shape. The soft starter was so that I could run this unit on a generator if I ever needed to, so that's completely optional. And on the bright side, it stops the lights from flickering in the house, because this thing would start at 110 amps and the lights go whoomp. It's just annoying. So that's a lot better too. So this thing should be able to last at least till spring. I hope it lasts longer, but next year I'd like to get a new unit. So that's all I have for this video. I hope you found it enjoyable, and I will see you all next time.